Hey Algebra 2, here are your notes for logarithms and logarithmic functions. I'm super excited because these are some of my favorite math concepts to work with, just because all we're doing is we're going back and forth between two forms of the same exact thing. So our biggest challenge is to convert from something called exponential form to logarithmic form. However, if you know these two things, converting back and forth is actually kind of fun, in my opinion anyway. So let's just see how to convert back and forth. The easiest way to learn these is to just do some of them. So if we want to evaluate each expression, the first thing we need to notice is which form is this in. Notice the exponential form is going to have an exponent. Notice the logarithmic form is going to have a log. So if we start out with a log, we know we're in logarithmic form. So we know currently that we are in log base b of n, and it's not equal to anything right now, but it could be. Eventually we will see somewhere they're equal to something. So how do we go from one form to the other? Well, I notice my b in this one is going to be 3. And when you're starting out, I kind of like to write out what each thing is just so I can, again, visualize a little bit more. I notice my n in this form is 81. So then when I want to go back and take it into exponential form, I can pretty quickly do that. I know my b is my base. I don't have a p for power, so I'm just going to put a p there as my exponent. But I do know that it equals 81. And to solve for this and to evaluate, all I have to do is figure out what value of p works. Now, there's a couple different ways to do this. I can throw it in a calculator. However, I just like to brain power it. 3 times 3 would be 3 squared. So that would raise to a power of 2. However, that's only going to get me to 9. If I multiply by 3 again, that's 27. That's 3 to the third. Still not get me where I need to. But adding another 3 will get me up to that 81. So I notice that I've multiplied 3 4 times. So a power of 4 will get me the answer I need. Again, maybe you're someone who prefers to write this out. I'll show you on the next one, I guess. But you could write this out as a base to see what the powers are. I prefer to just use my noggin. All right, let's see that again, though. Again, my base here is going to be 8. My n is going to be 1. So when I throw it into exponential form, I'm going to have 8 to the power equals 1. Now, how do we solve something like this? Well, you have to remember our powers of exponent. Our power rules and our exponent rules. The only way for something to be raised to a power and equal 1 is for the power to equal 0. So the only way here that we could make 8 equal 1 is if we raised it to the power of 0. All right, let's see another one. This one I think I'll be able to show you the different base. So b equals 4, n equals 2. Throw that into my information. 4 into my exponential form. All right, how do I solve this one? Well, the other way we can do this if we're not just super brain powered is we can write this as a base of 2 raised to the 2p like we saw in my last video. Because we know 2 has a power of 1 on the right side. So if you're not into brain powering it, make sure your bases are the same and use our information that says, I know the exponents have to be equal. So when I set them equal, I get 2p equals 1 or p equals 1/2. Just like that. Let's see that again with something a little bit bigger. My base is 2. My n is 256. 2 raised to the what power is equal to 256. I can rewrite 256 as a base. It's a little tricky to do if you don't know it off the top of your head, but you can just divide by 2 until you get what you need. So that's 1, 2, 3, 4, 5, 6, 7. And then the original one, of course. So 2p is equal to 2 to the 8th. And I can double check that. I counted only 7, but I have to include the original 2. So this would be 2 to the 8th. Notice I set the exponents equal to each other, and I get p to the 8th. All right, with a little less explanation, a little bit less work shown. 2 to the p equals 1/4. 2 to the what? It'd have to be -2 to flip this down. So p equals -2. 11, p equals 11. P has to equal 1. All right. So you've seen a ton with the logs, but we haven't seen anything where we had that p on the right-hand side where it was set equal to something. However, same name of the game. B is still equal to 5. Now I just don't know my n. Before I knew it, now I know something different. I know my p, which is 4. I still plug it back into my exponential form, which allows me to write it as 5 to the 4th equals m. Throw that in a calculator, and you get that it is 625. I almost think this one's easier because there's no solving trying to figure out what the exponent is. It's just usually throwing it in a calculator or solving for x. All right. 2 raised to the 3x equals 32. I can do this really quickly because I've pretty much memorized the forms. However, I would suggest when you're doing homework or working on this starting out, I would have these two forms next to me and I would definitely write those examples as well just to see what it looks like. The more you do these, the easier it'll be to memorize and remember those different forms. But until you do, no shame in just having it nearby. This is going to equal 2 to the 5. So 3x equals 5 when they have the same base. Therefore, x equals 5/3. All right, same thing here. 3 to the -2 equals 2c. 1/9 equals 2c. Divide both sides by 2, you get c equals 1/18. Like I said, these can be really fast once you get to know those formulas really well. All right, this one's a little tricky because it doesn't quite look like what we're used to. However, very similar to the exponent rule we had back up here, where if they have the same base, they have to have the same exponent. When you put these into that form, the exponential form up above, you're going to find out that if they have the same base, in order to be equal, what is inside of these parentheses must also be equal. So we don't even have to put it in any of these forms. We can just automatically say whatever is inside the first parenthesis has to equal what's inside the second parenthesis in order for this to work. So move that over, we get x equals 4. Same thing in this one. If they have the same base, log base 2, what is in their parentheses must be equal. So we set it equal. X squared minus 6 has to equal 2x plus 2. This one's going to take us a little bit more work because there's an x squared involved, but have no fear, we got this. Minus the 2 over, we get 8 equals 0. This is going to be x minus 4x plus 2 equals 0. So x can either equal -2 or +4. However, just because I get 2 answers doesn't mean there are 2 answers. Make sure you always go back and check. Let's plug these back in. I get -2 squared, which is 4. 4 minus 6 is negative 2. Ooh, problem. We cannot have a negative inside of a log. That immediately is going to raise some red flags for us. So negative 2 does actually not work. Even if it works in 1, which it won't because this will end up being negative 2 as well. Even if it works in one of these, it will not work in the other. And it'll never work in either of them if you end up having a negative inside of your parentheses. Let's double check to make sure that 4 works though. 4 squared is 16, minus 6 is 10. So 4 is an okay answer. All right. Looks really gross. Don't panic. If we need to evaluate, all we're going to do is set it equal to x, and then we're going to solve for x to evaluate. And we're going to change this up just like we're used to with our 2 other forms. We're going to take it from exponent form now, down to log form. Even though there's already a log in it, we're starting with our exponent form. So what does this look like? We're going to say log 8 of x equals log 8 of 64. And all I've done there is take it from exponential form down to logarithmic form. I've moved some things around, made it look nice. From here, I see that they have the same base, so what is inside their parentheses must be the same. So this was a quick, easy fix of x equals 64. Same thing over here. We're starting in log form, and now we're jumping up to exponential form. So, change of base here. My 12 to the 10th goes over into my n condition, and my 12 becomes my base, and my p becomes my power. So 12 to the x equals 12 to the 10, and x equals 10. If you need to see more of these, there's a ton of great examples on Khan Academy where he goes through weird ones like this. My suggestion is get really comfortable with the stuff up here, and then this stuff will come a lot easier. All right, let me know if you have any questions.